Hi, Year 11s, this is Mr. Lim here again, and this is our video on pH and indicators in the acids-base series. So let's get started. Okay, this is what we're going to be learning about. All right, so let's get through it. Okay, the pH scale is a way to measure the concentration of hydrogen ions in a solution. Okay, so we're just trying to work out how many hydrogen ions are there, but it's not just the amount of hydrogen ions, it's the concentration of them. Okay, so it's concentration, so it's got to be related to volume. The pH stands for power of hydrogen, which relates to the means in which the value is calculated, which is a logarithmic function. Okay, so it's just the power of like 2 to the power of 4 or to the power of something else, so it's power of hydrogen. All right, the pH scale is a logarithmic scale, which means it is not a linear scale. Okay, in a linear scale, 2 is double of 1 and 4 is double of 2, and you understand you can go up by 1, 2, 3, 4, and they go up in single units. Right? All values change in a linear way. That's the kind of scales that we're used to. However, this is a different scale. It's a logarithmic scale, and each change by 1 is a 10 times change. Right? So the difference between 1 and 2 is a 10-fold change. Okay, so it's very actually similar to the Richter scale, where you've got an earthquake of magnitude 6 and an earthquake of magnitude 7. An earthquake with magnitude 7 is 10 times as bad as an earthquake with magnitude 6. All right, and so therefore between 1 and 2 there's a 10-fold change, but that means between 2 and 3 there's another 10-fold change, and so therefore between 1 and 3 there is a 10 times 10 change, which means it's 100 times bigger or smaller. All right, this allows it to measure very small or very large concentrations and still use regular integers. Okay, so that's why they actually also use the Richter scale, because instead of saying how many gazillion joules, they or using scientific notation, they can just use normal numbers. So you don't have to use extremely small or large numbers or scientific notation. All right. The pH scale is used for biological conditions, which means that's within the range that's generally considered normal for biological life. So it's actually quite measures very, very low concentrations of hydrogen ions. The pH scale can be used for values outside of biological conditions, but then the numbers start to look unusual, and we'll talk about that when we get to some of the calculations. All right. Okay, so the pH value of solutions can be any number, okay, including negative numbers, but they are generally between 1 and 14. Values between 1 and 7 are generally acidic. Values between 7 and 14 are generally basic, and the value of 7 is generally neutral. Okay? The closer you get to 1 and 14, the stronger the acids and bases. So it's effectively going away from number 7, right? And then the further away you get from number 7, the stronger the acid or bases. Okay, now the important idea here is that these ranges hold true only at 25 degrees Celsius. Okay, so when you change the temperature, you change the nature of the solution, and we'll learn more about that in year 12. But remember that it's not like the value of 7 is not always neutral when you get outside of temperatures of 25 degrees Celsius. All right, so let's move on. Okay. So these things, indicators. So indicators are substances that can be added to acids and bases to change color when in acids and bases. Okay, so this is useful because acids and bases generally have identical appearances. So they look exactly the same. So a beaker full of hydrochloric acid looks the same like a beaker of water and a beaker of sodium hydroxide. Okay, they're hard to distinguish between because the substances that make it acidic or basic, the hydrogen ion or the hydroxide ion, have no color. Okay, so what we do is that we use these indicators to tell the difference between acidic and basic substances, right? We've got litmus paper, which will go red in acidic substances and go blue in basic substances, okay? Or you can add in a bit of universal indicator, which will change color from red to violet depending on the pH of the substance. So here you have it here. This is the pH values at the top, all right? And so when you go from 0 to 14, these are the colors that generally universal indicator will change into, all right? So that is pH and indicators, and then we're going to go into some calculations in the next video. Adios.